Good morning, class. This is Mr. Eggleston, and this is Algebra 1, Lesson 8.2, Exponential Functions. In today's lesson, the learning targets are that you will understand that patterns represent repeated multiplication. Okay, repeated multiplication. It can be described with exponents. All right, so when you have repeated multiplication, you can rewrite it with exponents. And you're going to learn how to write explicit rules for geometric sequences using the initial term and the common ratio. All right, so it has to do with this. Let's say you had let's say you had 4 times 3 times 3 times 3. You have 4 times 3 times 3 times 3. You can write that as 4 times 3 to the 1, 2, 3 power, third power. All right, so we could do it that way. And so there you go. So here it is. Visitors to a popular gaming blog are invited to subscribe to a newsletter for gaming news, reviews, and tips. The number of subscribers, T weeks. Gotta know what T is in terms of. It's in terms of weeks. After launching the blog can be modeled by the function S of T equals 27 times 1.035 to the T power. And the first question is, how many subscribers are there when the blog is first launched? Show how you figured it out. Well, since T weeks after launching, that means right when you launched it, T was equal to 0. So basically, when you first launched, it would be S of 0, which would equal 27 times 1.035 to the 0 power. Any number to the 0 power is 1. So that's 27 times 1, which is 27. So when they first started their blog, there were only 27 subscribers. Is the number of subscribers from week to week getting bigger or smaller? How many times bigger or smaller? Explain your thinking. Well, if you look at this, the original amount was 27, all right? So we had 27. Then the next week, or was it T weeks? Yeah, so the next week would be 27 times 1.035, which is 1035, which is a number, you're multiplying by a number larger than 1, so that result is bigger than 27, which was the original amount. So you would say each week, the number of subscribers is getting bigger. Bigger each week. Okay. What that means, it grows by multiplying by 1.035. So we're multiplied by a number larger than 1. And thus the number of subscribers is bigger. Okay, it's growing. It's not growing a lot because it's marginally over 1, right? Because it's 0.035, but it is getting bigger. So how many subscribers are there after 1 year? Well, that's basically we're going to use the expression they have. So that would be 27 1.035. Now, it's after 1 year. And T is in weeks, so this has to be to 52 power. So that's 1 year. Okay? And you calculate that, and you get 27 times 1.035 to the 52nd power. And that works out to be 161.53. So it's this, which is about 162. I'm going to round up because it's 0.53. So after 1 year, there's 162 subscribers. All right. Now, they want after 2 years. So 2 years, it'll be 27 to the 1.035. Now, 2 years is going to be 2 times 52, which is 104. So it's to the 104th power, which is a lot of multiplication. Okay. So upon doing that, you got to use your calculator. 1.035 raised to the 104th power actually is 35.79. Now we're going to multiply that by 27. That's our initial amount. And you would have 966 people. It's actually 0.4, but we're going to round down. So it's 966 people, our subscribers. Okay? And then 3 years, okay, would be 27 times 1.035 times 3 times 52, which is, 3 times 50 is 150, times 2, or plus 2 times 3 is 6, so it's 156 power. All right, to the 156th power. And so we go 27 times 1.035 raised to the 156th power. And that comes out to be 5,782. 5,782, because I rounded up subscribers. So there you go. That's how you can calculate this. Those. Simple. You just plug it in and use a calculator to evaluate. All right? Now, the next question, describe how the number of new subscribers differs between the first year, the second year, and the third year. So they want to know by how much is it growing. All right? So to do that, all we're going to do is find the differences. So, okay, so we're going to describe how the number of new subscribers differs between the first year, the second year, and the third year. So, between the first year, after 1 year, there was 135 new subscribers, which is 162 minus 27. 35 new subscribers. Okay. In the first year. Then after the second year, there were 804 subscribers. And what we're doing is taking the differences. Okay? So there's 162 after the first year. So we went 27 minus 162 and got 135. Then after 2 years, there's 966. And we subtract from that 162, and that gave us 804 new subscribers. So they're doing differences. Okay. In the second year. And then there were 4,816 new subscribers in the fourth year, or in the third year. Okay. So you see, we're not adding the same amount each time. So this is not arithmetic. This is not a linear relationship because we're not constantly adding. We don't have a common difference. Okay. Why do you think this happens? Because as more people discover this blog, they will tell more people who will then watch it. And so it'll keep growing. As more and more people have seen it, that number of people will go and tell people about it. And so there'll be much more subscribers. So it grows exponentially. All right. Because this is an exponential, not linear growth. Because we're not adding the same amount. Exponential, not linear. Okay? Because no common difference. You're not adding the same number each time. Okay? All right, so it's a common ratio because if you look at this, you would have 966 divided by 162. Those are consecutive numbers in weeks, and that's the same ratio as 5,782 to 966. Okay, so it's a common ratio over equal intervals. Okay, so there you go. It's an exponential growth. Now, some companies like to report the number of subscribers or sales after 100 days as a way to measure success. It's a common, number they look at, that companies look at. So how many weeks? Because remember, T is in weeks. So this says T equals weeks. So we have to turn 100 days into weeks by saying there are 7 days per week. So we take 100 divided by 7, and that'll give us the number of weeks. 100 divided by 7 is 14.29 to 2 decimal places. And that's weeks. So how many subscribers does the blog have after 100 days? Well, that would be S evaluated at 14.29, which equals 27 times 1.035 raised to the 14.29 power. All right, so 27 times 1.035 raised to the 14.29 power gives us 44 subscribers. Actually gives us 44.14 subscribers with a lot of decimals. And since you can't have a 0.14 subscriber, we're just going to round that down to 44 subscribers. Okay. So you see, by that we can evaluate these functions, these exponential functions, at decimal numbers. It doesn't have to be a 1, at 2, at 43, at 14. It can be in between. It's a continuous function is what they call it. All right, and finally, the learning targets. Number 1, geometric sequences are examples of exponential functions, which grow by a constant multiplier, which we call the common ratio. R, exponential functions can be evaluated for all real numbers, not just whole numbers, but it only makes sense in some contexts to evaluate at whole numbers, and other contexts it will make more sense to have it at the fractional decimal numbers too. All right, like in the case of the subscribers. Now, the general form of an exponential function is y equals a times b to the x, where a is the initial value and b equals the growth or decay factor, which is just the multiplier, what we're multiplying by. All right, if b is greater than 1, it's growth, and if b is less than 1, it's decay. Now, they say if b is between 0 and 1 because b can't be negative. So, all right, and there you go. Have a good day.